In northern Chile sits almost 41,000 miles of rocky, arid land known as the Atacama Desert. Next to Antarctica, it is the driest place on Earth.
There's some locations where it's never rained in recorded human history there.
While there is a shortage of rain here, there is an abundance of fog.
The limited moisture that it does get, it actually rolls in from coastal fog coming in from the Pacific Ocean, because the desert itself is sandwiched between the ocean and the mountains.
What's interesting about this desert is it's not relatively the hottest desert. It sits at 8,200 feet above sea level. It still only gets about 0.2 inches of rain per year though.
While the Atacama is typically a very dry, desolate landscape that looks even otherworldly, occasionally after we do have some rains, we can have these beautiful wildflower blooms where we have these purples and yellows covering this landscape, and for a few short weeks, it can actually create quite a beautiful sight.
The rare transformation is known as a superbloom, or desierto florido, the flowering desert. The bloom typically happens every 5 to 7 years.
The seeds of these wildflowers can lie dormant for months or years across the landscape, but when we do actually get that rainfall, that water helps to get rid of that protective coating around the seed, allowing them to germinate and create these beautiful scenes.
Between short periods of heavy rain and incredible blooms, the Atacama's 41,000 square miles remains dry and barren. Scientists estimate conditions here date back 150 million years, while the desert's inner areas has been hyper-arid for roughly 15 million years.
On the eastern side, you have the Andes Mountains, so the tropical moisture that comes in from the Atlantic doesn't make it up and over the mountains, so it's very dry coming in from the east. On the western side, you have cold ocean currents.
This particular current is called the Humboldt Current, which can actually transport very cold ocean waters from the Arctic and the South Pacific all the way north until it eventually dumps out into the warmer waters of the equator.
As the cold ocean water dumps out into the warmer waters off the west coast of Chile, the Humboldt Current draws the coldest water from the bottom of the ocean up to the surface, and the wind carries the cool air inland.
The Humboldt Current also acts as a reinforcing factor to keep it dry. Because those ocean waters are so cold, it's not very good for evaporating. You're not easily evaporating water.
The result is what scientists call thermal inversion. The warm, moisture-filled air is higher up, while the cold, dry air closest to the Earth keeps rain-producing clouds from forming. As it is a cold current, it brings fog to the nearby coast, but also helps to keep it one of the most intensely arid areas in the world.
You would think with all that coastal fog and mist rolling in that they would be a little bit more moist. Well, it doesn't necessarily equate to precipitation. Just because the fog is rolling through doesn't mean it's actually dropping to the surface.
So there are places in the world that it's surprising, I know some people are surprised by this, that will get fog but will not get rain.
Remarkably, some people have found a way to harvest the fog.
There's plenty of countries where fog water collection has taken place. The Atacama Desert in Chile is one example.
Here, some farmers carve out an existence in one of the most unforgiving places on Earth.
As humans, we need it constantly. We're supposed to have a certain amount of water per day.
Daniel Fernandez is a professor of applied environmental science with Cal State University in Monterey Bay.
I started thinking about fog and wondering if fog could be a resource that we could use in some way to help replenish our water. That's where I got the idea.
The idea: create drinking water out of thin air.
Fog consists of tiny little droplets of water, and if there's nothing to intercept their flow, those droplets of water will eventually evaporate. However, if there's a tree or some sort of other vertical structure that those droplets will hit, such as the fog collectors behind me, the mesh in them consists of a lot of little ribbons and a lot of little threads, basically. And those provide surfaces that the little droplets can actually collect upon, grow, and then drip down.
Scientists call it fog catching.
The design of these fog collectors is quite simple. There's a mesh here that's suspended by a copper frame that's mounted onto a couple vertical aluminum poles. And then there's a trough here that's angled so that when the water drips down off the mesh, it runs down the trough and enters into a tipping bucket rain gauge that measures it.
Under the right atmospheric conditions, fog catchers can harvest up to 3 gallons of water a day. Tapping into the power of fog forever changes the lives of those living not only in desert communities, but around the world.
Water is critical to life. It's crucial to our survival, and it's crucial to any life that we know of on our planet's survival. If you don't have water, then life is going to stop.